Now let's talk about the periodic property of tangent, which again really just means the repeating property of tangent. So we go in here. The reason why it's separate is because tangent actually repeats at a different radian amount than cosine and tangent. Okay? What did I just say? Cosine and sine. Okay? Cosine and sine repeat after 2 pi. But tangent actually repeats every pi radians. And I'll prove it to you. Okay? So let's draw a unit circle. Again, we're going to make our T angle. We're going to put our point P. We're going to call it x comma y. Okay. And this time we don't care about cosine tangent, so we're not going to do anything with that. Now let's look at what happens if we add pi radians to our angle. Okay, so we're just going to go 180 degrees around pi radians and end up in quadrant 3. And here we're going to put a point Q. Now this is directly across from the point P, which is x comma y. So over here, Q is going to be negative x comma negative y. Well, if we find tangent of T, our angle up here, that's equal to y over x. If we find tangent of our larger angle, that's tangent of T plus pi, then that's equal to negative y over negative x, which is the same as y over x. So these two are equal. If these two are equal, that means that these two are equal. If tangent of t equals y over x and tangent of t plus pi equals y over x, then these two are equal, which gives us our third identity. Which says that tangent of pi plus t is equal to tangent of just t. Alright, so there's our 3 identities. Now let's do an example problem over here. So say we have tangent of 225 degrees. Well, because of our identity, we can actually break that up. Before we would have to draw the reference angle and everything. Now we can just say, well, let's break off 180 degrees. So let's write this as tangent of 180 plus whatever's left over to make it 225. Do a little mental math, it's going to be 45. So what that means is that this equals tangent of 45 degrees. And tangent of 45 degrees, if you guys are starting to remember those, that's just equal to 1. And we're almost done. The only thing is we do have to worry about what quadrant it's in. Okay, in our first example it didn't matter because 420 is in the first quadrant. But down here, 225, no, we don't have to care because all students take calculus. Yep, that's going to work out. And so we're done. That's it. It equals 1. Now, we haven't talked about the reciprocals. So this is sine, cosine, and tangent. Well, the periodicity, yeah, is the same for their reciprocals. So over here, we can do an example of cotangent. So say cotangent of 495 degrees. Whoa, that's really big. So we're going to have to break off a big chunk there. Okay, we can say that that's equal to cotangent of, how many 180 degrees goes into that? I think I need a calculator. Okay, so 495 minus 180 minus another 180. Okay. So it goes into it twice. So we're going to break this into 360 plus whatever is left over, which is 135. Now for this one, it's kind of silly because that means we're actually going to have to draw a quick reference angle. So this one, it might be better just to draw your reference angle from the first place. Because now we have to draw a reference angle for 135, which is going to be about right here. So if we keep going, that little angle in there is 45. We have 1, 1, square root of 2. So cotangent of 135 is equal to 1, but it's negative because all students take calculus. And there you go. So there we still had to draw a little reference angle. Alright, well that's it. Go ahead and glue that in, and then I'm going to give you some examples to work on your own.